All right, so got some practice problems here. Question reads, what is the molarity of 675 milliliter solution? I got just a second, get my tablet going. Okay, here we go. A 675 milliliter solution containing 5.18 grams of Na2SO4 period 10H2O. Okay, so essentially what we need to do is we need to figure out the moles, divide that by our volume in liters. We're given our volume in milliliters, so we need to convert milliliters to liters. If you have a solution, well, so what we can do with that is say that 1 liter equals 1,000 milliliters. Therefore, 1.00 liters equals 1,000 milliliters. Therefore, 900 milliliters equals 0.9 liters. So I'm going to take this 675 milliliters and convert that to 0.675 liters. Okay, so that's part one. Now part two, part two is, so I'm going to go ahead and put a little check mark by my volume. I figured that out because that was just a simple conversion. Part two is my number of moles. And in order to figure that out, I got to look at my compound. My compound is Na2SO4 10H2O. This is sodium sulfate, but it is a ionic compound that's complexed with 10 water molecules. So this is sodium sulfate decahydrate. So what you need to do whenever you're confronted with this is you need to figure out what is the total mass of this. So in order to answer that question, you got to figure out what's the mass of Na, because there's 2 of those. What's the mass of S, because there's 1 of those. What's the mass of oxygen, because there's 4 of those. And I'm just going to keep that H2O as its own because that's one that I kind of know off the top of my head. And I know this by looking at the periodic table. This is ptable.com. Oxygen is approximately 16 grams per mole. So I can go back over here. I can say, oh wait, where was I? No, that's not what I want. This right here. So oxygen is 16. So 16 times 4 equals 64. But I also know that oxygen is 16 up here, and I know that hydrogen is 1. There's 2 of them, 1 gram. So 2. So water, each water molecule or each mole of water is 18 grams per mole. And so since I want to figure out, I'm going to erase some of this. I want to figure out what is the total molar mass of this whole thing. Well, I know that I've got 10 waters, so I'm going to take that 18, multiply that by 10. That's 180 grams. Okay, next up, I'm going to go back over here, my sodium and my sulfur. Go back to my periodic table. I see that sulfur is 32 grams, and 32.06, and I see sodium is 22.99. So I'm going to go back. This is 32.06 and 22.99. Okay, so 22.99 times 2, I'm going to round that to 23, and I'm going to say that is 46. Okay, now sulfur is 32, so I'm going to say 1 times 32.06 is 32. So I've got all these numbers, I'm going to add all of them up. So 46 plus 32 plus 64, that is 78. 78 plus 64 is 72, 142 plus 180. grams equals 322 grams. Okay, so now what I've got is I've got my molar mass for the substance. So that means that 1 mole of Na2SO4 decahydrate is 322 grams. So we're good. Now the next part of this, I'm going to erase what I've done over here. I need to use the mass that I've been provided with. And the problem tells me what mass of it that I have. It tells me that I've got 5.18 grams. So what I need to do for this is I need to set up some dimensional analysis. 5.18 grams. I'm going to write out Na2SO4 10H2O. 322 grams Na2SO4 10H2O. Okay, so what I did was I took what I know, which is right here, and then the relationship that I'm comparing it to. Okay, that's 1 mole Na2SO4 10H2O. Okay, so 5.18. So what this ultimately is 5.18 divided by 322. So I'm going to get my calculator, switch my share to my calculator. 5.18 divided by 322 equals 0.16. So I'll take that number back to my problem here. 0.16 or 0.01608 moles. Okay, so now I've got my number of moles. So now all I have to do is I'm going to bring this down here, 0.01608 divided by 0.675. So I'm just going to go back to my calculator. I haven't changed anything with my units or anything like that, so I don't have to worry about significant figures. I can divide this by 0.675, and I get an answer that is 0.0238. Again, go back to my presentation, equals 0.0238. Okay, so now what I'm left with is all my different answer options. Okay, so all of these numbers with this times 10 to the negative third, negative second, and so on, that's displaying our scientific notation. Or yeah, it's displaying it with scientific notation. Now, we've been given a decimal position. When we have to move in order to get this to kind of fit a decimal or to fit scientific notation, if it's moving to the right, then we are going to have a, just a second. We are moving it to the right in order to give us a, I guess, kind of properly placed decimal. This is going to therefore be 2.38 times 10, and it's going to be a negative exponent, which all of these answers are negative exponents. The question is, what's the number? Well, we have to move it 2 places. So it's going to be 2.38 times 10 to the negative second molar. And lo and behold, answer number 2 shows us that. All right, next up, the single largest use of phosphoric acid is in the production of fertilizer. How many grams of phosphoric acid with excess ammonia are required to produce 400 grams of NH4 2 HPO4, a common fertilizer? So what this question is asking is we've been given, okay, let me make sure I got my mind straight on this one. What we want to do is we want to make 400 grams of NH4 to HPO4. We want to know how many grams of this right here when we have an infinite. So I'm going to draw my infinity symbol right here. Okay. So what we need to do with this is we need to see the molar relationship between H3PO4 and our product. I only look at those two because we've been told there's an infinite amount or there's excess of this. So we don't care about the NH3. All that we care about is the H3PO4. Now what we're going to do is we're going to start and work backwards. We know that we want to make 400 grams of NH4 to HPO4. What we need to know is we need to know the molar mass of NH4 to HPO4. So to get that, we're going to go to our periodic table. And we'll get our periodic table right here. And what I'm going to do on a separate piece of paper is nitrogen is 14. H is 1. P is 31. And O is 16. All of these numbers are coming from right here. I'm just rounding them up a little bit. Okay, so now what I will do is clear all those drawings, go back to my presentation here, and I'm going to add all of these components up. How many nitrogens? Well, I've got 2 nitrogens. How many hydrogens? Well, there's 4 here, there's 2 here, so that means there's 8 hydrogens. But then there's another hydrogen, so I'm going to change this number from 8 to 9. How many phosphorus? There is 1. How many oxygen? There are 4. So this would be 28. I'm just doing the multiplication kind of on the fly. There'd be 9, and I'm adding up the mass of all of these. Phosphorus is 31, and oxygen is 16, so 4 times 16 is 64. So add all of these up. 28 plus 9 is 37. 31 plus 64 is 95. 95 plus 37 is going to be 132. So 132, yeah, that's right, 132 grams. Okay. Now, what I'm also going to do is I'm going to figure out the mass of my H3PO4. I've got all the same components, so I'm going to say 3H, 1P, and 4O. 3H is 3, 1P is 31, 4O is 64. So I'm looking at a total mass for H3PO4 that is 98 grams. Now what I'm going to use this for is I'm taking the mass of my NH4 to HPO4, and I'm going to do a molar relationship between that mass and my H3PO4. That's my aim. So I'm going to say 132 grams of NH4 to HPO4. Then I'm going to say that's 1 mole of, and I'm just going to call this NH4 to HPO4. Okay, so now I've got the conversion from my mass with my molar mass. So the mass that I have relating my molar mass to the number of moles. And then what I'm going to do is I'm going to look at the number of moles, 1 mole of NH4, HPO4, 2, and 2 is 1 mole H3PO4. And I know that's 1 to 1 because what coefficient do I have in front of each of these? I don't have a coefficient, which means it's 1 and 1. Okay, so now the last part of this is 1 mole H3PO4. That 1 mole, so now I'm doing mass to mole, mole to mole, and then a mole to mass conversion. And this is 98 G. Okay, so now what I want to do is I'm going to multiply across the top and then divide by what's on the bottom. So I'm going to do 400 times 1 times 1 times 98. So 400 times 1 times 1 times 98. That gives me 39,200. Now I'm going to divide that by 132 because 132 times 1 times 1 is 132. So that gives me a final mass of 296.9696. So this is equal to 296.96, which is answer option number 5. Okay, next up. If 75 milliliters of 0.250 molar PbCl4 reacts with 30 milliliters of blank molarity of NH4,2SO4, what is the molarity of the NH4,2SO4 solution? Okay, so this is proposing it's basically saying that these two things, PbCl4 and NH4,2SO4, react perfectly with one another. Now, what we know is our balanced chemical reaction tells us that we have 1 mole of PbCl4 that reacts perfectly with 2 moles of NH4,2SO4. Okay, so what we know is we know that we have 75 milliliters of a 0.25 molar solution that reacts perfectly with 30 milliliters of a question mark solution. So the way that we can solve this problem is we can say what our volume, 0.075 milliliters of PbCl4 times 0.250 molar. That is going to be equal to, I can plug this into my calculator, 0.01875 moles PbCl4. What this tells us is that we reacted an exact 0.01875 moles of PbCl4 with our NH4,2SO4 solution. Okay, now what we know, and we want to relate this back to our balanced chemical reaction, is that 1 mole of PbCl4 reacts perfectly with 2 moles of NH4,2SO4. So the way that we're going to treat this problem from here is we're going to say 0.01875 mole PbCl4. I'm going to set up a dimensional analysis problem. My aim is to figure out how many moles of PbCl4 or how many moles of NH4,2SO4 actually reacted. So I'm going to say 0.01875 moles of PbCl4. Then I'm going to have 1 mole PbCl4 reacts with 2 moles NH4,2SO4. So I'm going to say that, this is going to tell me the number of moles of NH4 to SO4 that reacted. 0.01875 times 2 is going to be 0.0375 moles. 375 moles of NH4 to SO4. Okay, now the question was, what's the molarity? Okay, so all that we're going to do is we're going to take our number of moles and divide it by our volume in liters. So you have to take this 30 milliliters and convert it into liters to be 0.030. We can take our number of moles, plug that in there, and we're good. So 0.0375 divided by 0.030. That is going to be equal to 375 divided by 0.03. That's going to be equal to 1.25 molar, which is answer number 2. All right, hope this is helpful.